In this video, we're going to multiply and simplify expressions containing square roots. The first example we have has the number 3 times the square root of 6, and then we see the dot for the product, so we're multiplying that by the number 2 times the square root of 3. So our goal here is to get as few radicals as possible with the smallest numbers inside those radicals as possible. So the first thing we can do is use the commutative property of multiplication and turn this into 3 times 2 times the square root of 6 times the square root of 3. And the reason that I've used that commutative property of multiplication to reorder that is so that I can multiply the integers and then work with using the multiplicative property for square roots to simplify that square root 6 times square root 3. So 3 times 2 is simply going to give me 6. And then this square root of 6 times the square root of 3 I can turn into the square root of 6 times 3. And so when I do that, I'll still have my 6 out front, and now I have the square root of 18 under that. So I've got 18 under that radical. I'm almost done. I have a single radical instead of 2, but I need to see if that square root of 18 will simplify. And since 18 has 9 as a factor, which is a perfect square, it will. So we can rewrite this as 6 times the square root of 9 times the square root of 2. And that square root of 9 will just simplify to the number 3. So we have 6 times 3 times the square root of 2. And as a last step, 6 times 3 just becomes 18. So we have 18 times the square root of 2. Again, our goal there was to have as few radicals as possible with the smallest number possible inside that radical. Let's move on to our next example. We have the square root of 3 times, and now we have a sum. And so inside these parentheses, we have the sum of the square root of 12 and the square root of 5. Because we have, we're taking one number and then multiplying by the sum of another two numbers, we're going to have to use the distributive property. So as our first step, we will distribute that square root of 3 across that square root 12 plus the square root of 5. So the first thing we'll get is the square root of 3 times the square root of 12, and then we're adding the square root of 3 times the square root of 5. We'll use the multiplicative property for square roots to simplify each of these. And so the square root of 3 times the square root of 12 we can write as the square root of 3 times 12, and that 3 times 12 is then under that square root. Then we're adding the square root of 3 times 5. And again, that 3 times 5 is under that second square root. So simplifying each of these, the first one will become the square root of 36. And the second, so now we're adding the square root of 15. So we have the square root of 36 plus the square root of 15. The next thing I want to do is look at simplifying each of these radicals, and if possible, seeing if anything can combine. So the square root of 36, that's simply going to be the number 6. The square root of 15, as I look to simplify it, 15 is not a perfect square, so it does not become a positive integer. And it also does not have any factors that are perfect squares. So the square root of 15 is fully simplified. So as a final result, I'll have 6 plus the square root of 15. Moving on to examples C and D, I'm again going to have to use the distributive property. And actually, I'm going to use the FOIL method here to make sure that I keep track of all of my terms. So this first one, I have the square root of 7 plus 1. I have that number, and then I'm multiplying that by the number the square root of 5 minus 3. So I'm essentially having a binomial times a binomial is how I'll think of this, and so I'll distribute and use that shortcut FOIL method. So I'll multiply the first term, square root 7 times square root 5. I'll do the outside terms, so I'll have the square root of 7, and then I'm multiplying by a negative 3, so I'll have minus 3 times the square root of 7. And then the inside, I have positive 1, square root of 5, so I'll have plus 1 times the square root of 5. And then for those last terms, I have positive 1, negative 3, so I will subtract 3. Simplifying this, that first expression, I have the square root of 7 times the square root of 5. I can turn that into the square root of 7 times 5. The next one, I'm subtracting 3 times the square root of 7. There's not anything I can do to simplify that, so I'll leave it as is. And then I'm adding 1 times the square root of 5. Again, that can't simplify. In general, I'll write it simply as the square root of 5. So I'll put plus the square root of 5. Then I'm subtracting 3, and again that can't simplify at all. The last thing I can do is simplify that square root of 7 times 5 into the square root of 35. So I have the square root of 35 minus 3 times the square root of 7 plus the square root of 5, and I'm subtracting 3. Again, we know that the square root of 35 can't simplify any further because there aren't any perfect square factors of 35. In this last example, we have the number, the square root of 8 plus the square root of 11, and that whole quantity is squared. So the first thing we want to do is break this down into the product. So we'll take the square root of 8 plus the square root of 11, and then we'll write times the square root of 8 plus the square root of 11. There are shortcuts for taking the perfect square of a binomial, but breaking it down into this way and then foiling is one approach that can help us keep track of our terms. So I've broken it down. I've taken that squared and made it a product of the square root of 8 plus 11 times itself, and now I'm going to use FOIL to keep track of all of my terms. So I'll multiply those first two, so I'll have the square root of 8 times the square root of 8. Then I'm going to add the product of the first and the outside, so square root 8 times square root 11. And then I'll do the inside, and so I'll have the square root of 11 times the square root of 8. And then on the last one, I have the square root of 11 times itself. So write square root 11, square root 11. Simplifying this, the square root of 8 times the square root of 8 would become the square root of 8 times 8, which is the square root of 64 and gives us 8. We also know that taking a square root of a number and then squaring it will just give us that number. So we know that the square root of 8 times the square root of 8 is simply going to be 8. And then for this next one, we have the square root of 8 times the square root of 11. And so I'll move that inside there. I'll make that the square root of 8 times 11. And then I'm adding the square root of 11 times 8. Those are going to be the same when simplified. And again, that's because of the commutative property of multiplication. For this last term, I have the square root of 11 times the square root of 11. And that is simply 11. All right, so for my last step here, I have the square root of 8 times 11, square root of 11 times 8 are the two terms that I still need to simplify, and then 8 and 11 I'll be able to combine. So I'm going to first combine that 8 and 11, they're like terms, so they'll be 19. And then looking at simplifying this, I have two of this square root of 8 times 11. And so I've combined those. They are like terms. And the last thing I want to do is break down that square root of 8. So I'll have 19 plus 2 times the square root of that product, 8 times 11, become 19 plus 2 times the square root of 4 times the square root of 2 times 11. And as my last step, 19 plus 2 times the square root of 22. And that was my second to last step. I've got one more. So I'll have 19 plus 4 times the square root of 22.